Hello, welcome back. In this video, we'll discuss the applications of nanomaterial. There are a variety of applications in almost all fields of engineering, science, technology, and medicine. Here we are listing out some of the applications that are relevant to engineering. The first application perhaps one can think of is tougher and harder cutting tools. The cutting tools made of nanocrystalline materials such as tungsten carbide, tantalum carbide, and titanium carbide. The tungsten carbide, tantalum carbide, and the titanium carbide, they are much harder, much more wear resistant, and last longer than their conventional counterparts. So benefits we get when we use the nanocrystalline particles of these materials, namely tungsten carbide, tantalum carbide, and the titanium carbide, are much more harder, much more wear resistant, much more erosion resistant, and further they last longer than conventional tools. The nanomaterials are also better insulating materials. The nanocrystalline materials are synthesized using the Soliel method results in foam-like structure called the aerogel, and these aerogels are porous and extremely lightweighted. The aerogels are composed of three-dimensional continuous networks of particles with air trapped at their interstitials. In the case of aerogels, we have air trapped in them. Because of the trapped air molecules, they become better thermal insulating materials. The nanomaterials are better thermal insulating materials. Namely, those materials that are synthesized using the Soliel method, they produce the aerogels. These aerogels are porous in nature. These aerogels, they also have air molecules trapped in them, because of which they become better insulating materials. They are ductile, missionable ceramics. Ceramics are not in general ductile, whereas the nanomaterials are made in the form of ceramics such as silicon nitride, silicon carbide. These are all materials that are ductile, nanoceramic materials. Low cost flat panel electrochromic displays. What are electrochromic materials? Those materials through which, when a current is passed or an external biasing is applied, certain absorption bands altered. Either they will disappear or new absorption bands are created. Such materials are called as electrochromic materials. One such example is the tungstic oxide, WO3XH2O. This is essentially a gel. This gel behaves like an electrochromic material. This material will have certain new absorption bands in the optical spectrum of these materials, and also the existing absorption bands in the optical spectrum, they will be modified when a potential difference is applied across the electrochromic material, that is tungstic oxide. These electrochromic materials, they are extensively used in display panels or billboards or advertisements. Elimination of pollutants. Using the nanomaterials, one can eliminate the pollutants in the environment, because the nanocrystalline materials possess extremely large grain boundaries relative to their grain size. The nanocrystalline materials possess extremely large grain boundaries relative to their grain size. Because of this factor, they possess active physical, chemical, and mechanical properties. Due to their enhanced chemical activity, nanomaterials can be used as catalysts to react with such noxious and toxic gases. These nanocrystalline materials, they contribute a lot to the environment. They can prevent environmental pollution arising from burning of petrol and coal. Using nanomaterials, one can develop high power magnets. The strength of a magnet is measured in terms of coercivity and saturation magnetization values. And these values increase with a decrease in the grain size and an increase in the specific surface area of the grains. The strength of the magnet is measured in terms of coercivity and saturation of magnetization values. And these values, the coercivity and saturation, they depend on the grain size. When the grain size is decreased, the coercivity and saturation values, they increase. And similarly, an increase in the specific surface area of the grains can cause a reduction in the coercivity and saturation. Some of the nanocrystalline materials, they possess very unusual magnetic properties due to their extremely large surface area. Such nanomaterials are extensively used in automobiles, alternators, land-based power generators, etc. High energy density batteries. The conventional rechargeable batteries are used in most of the electronic devices these days, and these applications include automobiles, mobile phones, laptops, etc. The storage capacity of these batteries is quite low and they require frequent recharging. The life of conventional rechargeable batteries is also low. Nanocrystalline materials synthesized by sol-gel method can be used to separate the plates in batteries. And this foam-like structure can hold considerably more energy than conventional ones. High sensitivity sensors. Sensors employ their sensitivity to the changes in various parameters they are designed to measure. The measured parameters include electrical resistivity, chemical activity, magnetic permeability, thermal conductivity, etc. All these parameters depend greatly on the grain size. A change in the sensor's environment is manifested by the sensor materials, chemical, physical, and mechanical characteristics. This is exploited for detection. For instance, a carbon monoxide sensor made of zirconium oxide uses its chemical stability to detect the presence of carbon monoxide. Aerospace components with enhanced performance characteristics. The aerospace components made from nanomaterials, they can enhance the performance of the components, enhance the desired characteristics of the components. The nanomaterials are also used as sunscreen. A sunscreen is a type of a body lotion that is applied to prevent the UV exposure. Conventional sunscreens, when they are applied, they give rise to whitish patch on the skin wherever it is applied. Whereas when nanomaterials are used to develop the sunscreens, they do not cause any patches. They will be transparent and one can make the sunscreen very, very thin without causing rashes. Self-cleaning glasses. They are made using two principles. One is photocatalytic and hydrophilic. The photocatalytic effect means that when UV radiation from light hits the glass, nanoparticles become energized and begin to break down the loosened dirt molecules on the glass. Hydrophilic means when water makes contact with the glass, it spreads across the glass evenly, which helps wash the glass clean. Thus, the glass is a self-cleaning glass. Clothing. By applying a thin layer of zinc oxide nanoparticles, the zinc oxide nanoparticles can protect from the UV radiation. Scratch-resistant coating. Adding aluminum silicate nanoparticles to scratch-resistant polymers makes them more effective. So we add aluminum silicate nanoparticles to scratch-resistant polymers to obtain much more effective scratch-resistant polymers or scratch-resistant coating materials. The list goes unending because of the recent developments in the nanomaterials. In this video, we have started our discussion with the toughness and hardness of the nanomaterials and how it can be used in cutting tools. After that, we have seen how nanomaterials can be used as thermal insulating materials. We have seen nanomaterial based ceramics that are possessing both ductile and ceramic properties, how they can be used in the industry. We have seen how the nanomaterials can be used in electrochromic displays. We have seen the elimination of pollutants using the nanomaterials in the environmental science. We have seen the nanoparticles application in high power magnetic materials. We have seen how nanomaterials can be applied to develop high energy density batteries. We have also seen their applications in the high sensitivity sensors, aerospace engineering, sunscreens in skincare, self cleaning glasses, clothing, and scratch resistant coating. Thank you.